This is experiment, if you're keeping track, I think this is experiment number 4. We'll get up through experiment number 5 and maybe into experiment number 6 today. But all of these, going back to Ariel's awesome question, involve analyzing an experiment and getting its population probability distribution. Now Vegas needs to know these kinds of things to know how much to actually make games cost people to ensure that they make money on the game. Okay, well, we're going to analyze that here momentarily, and then we're going to reanalyze it in the quiz, probably for next week. So here's the game of Chuck-a-Luck. Chuck-a-Luck. It's a pure game of chance. This is not a game like poker or blackjack where skill is involved. Okay, I find it very hard to analyze poker and blackjack because of that. You have to know something about when to stop playing, when to bet, how many cards to get rid of. That's not a pure game of chance. There's an element of chance to it, what cards you get dealt. But then there's also an element of skill, when to stop playing, when to get rid of cards, when to take more cards. This is a pure game of chance. You take 3 dice. They put in this thing called a bird cage, which is just, looks like a bird cage. It's like an hourglass, actually, like a wire hourglass. You come up to this table, and it's very, very basic. It's very, very basic. It looks like this. Okay, 1, 2, 3, 4, 5, 6. And you walk up to the table, and let's say you want to bet $1. We'll keep it at $1 bet for right now. You can change the bet to anything you want, but we'll keep it at $1. So you bet $1, and that's called your ante. We're going to use that word every once in a while today because it actually carries over to other elements of your life, like your car insurance. There's an ante in your car insurance as well, it's just not called an ante. So you bet $1 on one of those numbers. Go ahead.
6.
6 it is. 6 it is. I'll put our little dollar right here. 1, 1, 1, 1. I think money kind of stuff looks like that. Say that again?
I said, wouldn't it be a chip?
Sure. But I can't, it'd be easier to draw a dollar to symbolism. Vegas Carly. So we bet $1, put it on 6. We spin the bird cage, which has 3 dice in it. What happens? What happens? Why did you bet on 6? Cassidy, go. Actually, it's not adding. Very good. Very, very good. It's not. No, it's not adding. That makes it more complex. That'd be a fun game, actually. That'd be a fun game. It's not adding up to 6. It's actually seeing 6 on the dice. So that's the game. You then check. You spin the cage, or let's just say roll the dice. Roll the dice, and then count the number of 6s that you get. Okay? How many 6s can you get? 3. That's what you want in this game. You'll see why momentarily. What else could you get?
1 6.
You can get 1 and 2 non-6s, couldn't you?
2 6s.
You can get 2 6s and 1 non-6,
No 6s.
or you might not get any at all. Those are the 3 options, or the 4 options, excuse me. So what I'm going to do first on this side of the board over here, I'm going to make, it's not going to be part of the probability distribution, but it's going to help us keep track of when we make it. Pull this down so you can see what the hell's going on. We are going, can we see that? Yeah, we can. So we're going to put, I keep forgetting that's not blue anymore. Get a different color, it's orange. Number of 6s seen. So we just said we can either see none, 1, 2, or 3. That's what we can see. That's what we can see. The payouts that Vegas controls are based on that. They're based on that. Okay, so you spin the bird cage, you bet on 6, you see one of these 3 things. So what we're going to do is we're going to make the payout. We're going to make the payout be the random variable, because that really is, the number of 6s is the random variable, but it doesn't affect you as much as the amount of money that's changing hands. That's what's actually affecting you. Does that make sense? So we have to keep track of that. We have to keep track of how much money is changing hands. So let's suppose you bet the $1 on 6, and no 6s come up. What's your payout? Technically, what is it? It's -1, isn't it? You don't get any payout. You don't get any money back, but you bet $1 to play, which means you're at -1 right there, correct? Does that make sense? Good. So you're at -$1 right there. Fair enough? Good. What if you spin the bird cage and you see a 6, a 2, and a 3?
Oh, you get $0.
Good, you net $0 because they're going to give you your dollar back. So now you average out at $0 for that bet. That's exactly right, Nick. That's your break-even result. One of your numbers that you bet on. And and Monica picked 6. Please realize this works for any of the numbers besides 6, okay? So you pick. All right. How about if 2? What if you get 2 6s? $1 back. Exactly right. $1, but it's a 2-to-1 payout if you get 6s. 2-to-1 payout. So you're going to get $1 back. And what if you get 3? It's actually 10-to-1 payouts. So you'll earn $9 on that. So I'm going to put that over here. Yeah, this is how the game earned its popularity, is because of that, because of the 3-6 or the 3-5 or the 3-4. So if you don't roll any 6s, you just lose your ante. Put that in parentheses next to it. You just lose your ante. Fair enough? Good. Good. If you roll a 6, it's a 1-to-1 payout. So whatever you pay in, they give you that same amount back, which ends up canceling it out and becoming 0 because you earn back your ante. When you roll 2 of what you've got, it's a 2-to-1 payout. 2-to-1 payout, if you will. And this one here is a 10-to-1 payout. But the thing is, you had to pay the 1 to get the 10, which means you actually only profited 9. That makes sense? Is that believable? Awesome. So let's suppose you walk into Vegas, you find this game, which is getting harder and harder, but this one's losing popularity. I think it's because it's a pure game of chance. It's not as much fun as a game like poker. Craps is also a pure game of chance, but Craps is fun. Craps is a lot more fun because it goes really quickly, and it's seemingly simple, but there's nothing simple about the betting scheme. I want to analyze Craps in a later quiz because it's freaking awesome. But at the same time, this is a very simple betting scheme. So you walk into Vegas with a pocket full of money that you're ready to just blow on Chuck-a-Luck. And here's $1, boom. And you're going to play this game, and you're either going to lose the $1, win $1 back, and 0 out, +1, +9. My question is, suppose you do this game over and over and over and over and over again. And had I known the network was going to be down, I would have brought stuff to play it with today. Sorry. But on average, what would happen? On average now, this is what Vegas cares about. Vegas needs to know on average what happens with these 4 payouts. Because they need to control those payouts to make sure they're making money on you. So, if I asked you on average, what payout would you expect from this game? -1, -1. Why -1? How'd you get -1 from that? I'm curious.
It's overtime.
Overtime,
If you
-1?
have money back in there, you're going to lose.
Okay.
More options of 0, 1, and 2 than there are 3.
Oh, okay. I like you hear what Linda just said. Say that again, nice and loud, Linda.
Because there's more of 0, 1, 2, and 3 that you'll have the chance of getting those than you would with 3.
She's mentioning something about chance, which we haven't even talked about yet, have we? Right? Good. Hold that thought, Carly. Go.
Oh, I was kind of going to say along the lines of her that your chances of like getting at least one of them of the dice is like 1 in 6, right?
It's going to be good, but how does it change when you have 3 of them? That's good. I love what you're saying. You guys are both talking about chance.
50%?
Good. Let's hold that thought. Hold that. I want to get all your guys' ideas because I love what I'm hearing so far. We need to talk about that. Is anybody just add these 4 together and divide by 4? I mean, you can do that, but you shouldn't do that. Because if you add these 4 together and divide by 4, go ahead, Monica.
Sorry, it's going to go more toward the out.
It's actually going to target more towards the outlier. Tell me your name over here again. I'm sorry.
Kendra,
Kendra, go.
do you do 1 in 6 to the 3rd power?
What is that? What is that? I hear 1 in 6 to the 3rd power back there. What's 1 in 6 to the 3rd power?
18.
Say that again.
No. Just
No, but what for which one, Kendra? Which one are you calculating right now? What's this 3rd power thing you're mentioning
Well,
back there?
because you have 3 dice, so your odds don't multiply by 3
Good.
power of.
So you think back to your first project, the discussion we had yesterday or last class about 2 dice. Remember when we sat down and figured out all the outcomes for 2 dice? How many outcomes were there for 2 dice?
36.
There were 36, because 6 times 6 is 36. How many outcomes are there for 3 dice? 6 times 6 times 6, or 216 outcomes. It's 6 cubed outcomes. So basically, when you throw 3 dice, you're going to get one of those 216 outcomes. How many of them are 3 6s? Only 1. There's your 1 6 cubed. That was awesome. That was totally awesome. So I'm going to add a column to this, if it's okay with you guys, because I think we need that column, don't we? As per Linda and what Carly was saying, and Carly back there was also saying, we need to talk about the likelihoods of these things. And as Mon correctly said, we can't just treat this all as happening 25% of the time, because we can't prove they do. I think we can prove they don't pretty quickly, though. I think we can prove they don't pretty quickly. Here we go. Now, just FYI, what we're about to do is going to take us some time. I had a simulation prepared to actually get us these numbers. People almost always get, and thank you, Kendra, for getting the 1 and 216. That was fantastic. The 1 and 216 is an easy one to see because you know it's not going to happen very often. One time out of the 216, as a matter of fact. Beautiful. 1 out of 216. So that's roughly 1 in 200 trials. So if you've got enough money in your pocket to play 216 times, you can expect on average to hit the jackpot once. Now think about how that pays. I said on average, right? That's not a promise, it's not a guarantee. But think about it. It's going to cost you 216 bucks to win back 10. But then again, you're also going to win back stuff over here. The question is, how often do you win that stuff? So what I want to do now is, can we analyze the other probabilities in this distribution? How likely is it, for example, to not get anything that you betted on? What do you think? How likely is that? These are all out of 216, FYI. These are all going to be out of 216, yeah. What do you think? What do you think? How many different ways can you not get a 6? A lot. A vote for a lot? I think that coincides with what Linda and Carly said over there too. Like, you're pretty much screwed. It's going to be the most likely outcome, but the question is, how likely is it? What do you think? Ideas. Any ideas you have right now? Think back to your last project. This will help, actually. Go ahead, Di, go. So let's figure it out. Number of ways to not get 6s. So here are, if you will, the results of the 3 rolls of the dice. Fair enough? Now we just used something up here. We did 6 cubed. That would have been the number of ways to roll 3 dice. 6 times 6 times 6, right? Marty, what's on your mind back there?
So wouldn't it be 5s cubed?
Wouldn't it be now? If you don't want to roll 6s, what can this die here be?
5.
A 5, a 1, a 3, a 2, or a 4. There's 5 possibilities that die right there can be if you don't want it to be a 6. So there's 5 possibilities. Just like we said 6 cubed up here, it's going to be 5 here in the front because we just don't want it to be a 6. What should this die be?
4.
It could be,
5.
Can it be 5? I know it's tempting to go 5, 4, 3 because you're thinking of your last project. I was thinking more generally, you were multiplying in your last project. That's what we're doing here. If you get a 5 on the first die, couldn't you get a 5 on the second die?
Yeah.
You could. As a matter of fact, if you did that, you probably wish you better go 5 instead of 6. But nonetheless, you definitely have 5 possibilities again here. And how about here? You've got 5 all the way along, don't you? You've got 5 all the way along. So what's that, 5, that's 125? That's 125 out of 216 of the rolls are not going to have any 6s in them. So that's 111, 112, 113, 114, 115, 121. Cassidy's like, please stop talking. Good, because we don't want to do it that way. Remember the last project, the first page of the last project? When you were drawing from Punxsutawney Phil's groundhog predictions? That was only 16 times 15 and it was ludicrous. This is 125. I mean, then you have to figure out all the individual... Don't want to do it. Don't want to do it. Not worth doing. Cool? Awesome. So 125 of the 216 are now accounted for with the big loss. 1 of the 216 are accounted for the big win. What goes in the middle now?
If there's 1 6, it's going to be 25 out of 206.
Why?
Because it's the chance are 1 out of 6 times 5 out of 6 times 5 out of 6.
Now, this is going to get a little bit tricky. This part's going to get tricky. We now have to figure out, we'll do the 1 out of 6, we're going to do this one right here. So this means we have to figure out, I wish I brought my dice, because this would be great to actually have in front of me right now. Let's get the number of ways to, well, that would be trickier. I like the at least 1, and we would do that if I wanted to figure out this. But the thing is, I actually need each one of these exactly. So the word at least is not, to figure the distribution out is not going to help us, unfortunately. And this is actually the reason we're actually sneaking into next week here, what we're about to do. That's where the simulation was really going to come in handy, but we'll come back to that. Number of ways to get 1 6. Okay, so where's the 6? First of all, tell me where the 6 is going to be in these three.
First one.
First one, okay, so this is going to be the 6. I'm going to put little notes under that if that's okay to keep track of things. So this is the 6. This is the not 6.
And that'd be 5, 4.
And this would be not 6 as well. So give me an example of 3 dice falling that would fit this bill. 6, 5, 4. I like that. Good. How about 6, 1, 1? That would fit, right?
6, 2, 3.
6, 2, 3. Right?
5, 5.
6, 5, 5. Wish you bet on 5 again. Right? 6, 6, 2. Oh, no. 1, 6, right? Only 1, 6. So this one has to be a 6. So how many choices do I have for that die? I only have 1. I only have 1 choice for that die. 1 and only 1. Is that fair? And Cassidy?
Wait, no, sorry.
Are you, oh, here, 5 and 5? Yes, Carly? Absolutely. Cassidy asked me that question, though.
No, I was gonna say I have 3 dice.
Oh, you do?
Yeah.
On your phone? Hold that thought. That's beautiful. Oh, can you make them different colors by any chance?
Yeah.
You can? Make them different colors. Perfect. Hold that thought. Wish I had a document camera now. Keep wishing for things. Wish the room was cooler. So, how many choices do we have here?
5.
How many choices do we have here?
5.
Okay. Multiply together, make 25, yes? Good. So this should be 25 right here. Good so far? Now I'm going to leave that one up here. I'm going to scroll over to this board over here, because I want to come back to this one. I want to come back to that one. This is some interesting stuff. In your last project, you might have recognized, in your last project, we did quite a bit of time talking about none or all, but we ignored the middle of these distributions. You didn't even realize in the last project you were dealing with distributions. I was hiding that from you. But you were. But I never ever once asked you, what's the chance if you pick 5 people that 2 out of the 5 are tattooed? It was either none of them are tattooed, at least one of them is tattooed, all of them are tattooed. It was never in the middle. It was always the ends or the whole thing added together. And that's because these get interesting in the middle, as you're seeing right now. Good. So now let's go. How about number of ways? Number of ways to get 2 6s. Okay, 1, 2, 3. Here they are. Where should the 6s be? Carly.
In the first 2.
The first 2. Okay, so this is going to be a 6 here. This is going to be a 6 here.
Yeah, and then a not.
And this is going to be a not a 6. Good, non-6. So what are my choices?
1,
1, 1, and 5. Yeah? Makes sense? Yeah, 1, 1, and 5. 1, 5. So it should be 5 ways, yes? We have our distribution. We have our distribution. How do we know we have our distribution? Oh! Kelsey's saying, oh, no we don't.
There's not 216 ways
Damn it!
to be able to rearrange all of those.
Add those up.
Dice.
Add those up. Kelsey's noticed something very important. We're shy of 200. If you think about it, we have to add up the numerators, and the numerators have to add up to 216, because we have to have accounted for all 216 possibilities, yes?
Yeah.
So the problem is, 125 plus 25 is 155, 156 out of 216. We're shy by like 25%, it sounds like. Linda, what's the matter?
Maybe I missed it, but how'd you get the 1?
Oh, the 1 out of 216?
Yeah.
That was Kendra's awesome idea. Out of the 216 possibilities, only one of them is 3 6s. 6, 6, 6. That's it. You can't get a different arrangement of 6s. There's 1 choice for the first, 1 choice for the second, and 1 choice for the third. Does that make sense?
Yeah.
That's actually the way Kendra did it. She did 1 6 cubed.
Okay.
So she actually did the entire thing at once. Are we okay with this 216, first of all?
Yeah.
That's legit, yeah? That has to be legit, because there are 3 dice, 6 sides each. It has to be 216, so I think we're okay with that. So, are we okay? Let's go through this one by one. Are we okay with Kendra's 1 and 216? I'm totally fine with that, and here's why. Think back to 2 dice. Remember when you had snake eyes? I said, make snake eyes, and you all took your dice and you went 1, 1. And then at some point later on I said, make box cars, and you took your dice and you went 6, 6. I said, can you make box cars a different way? And you told me, no, because the 6 is 6. You're looking at it. You can't turn them and get different results or anything like that, right? Does that make sense so far? Okay, so This one's fine. 1 and 2, 16 is fine. Let's go back to the next one we found, which was the 0 up here. Are we okay with the 125 out of 216?
Yeah.
It sits well with us, I think, in a lot of ways, because it sits well with us. We knew it had to be large. And that's more than half of the probability is wrapped up in that one. So that sits well. It doesn't seem like it's too small. But did we account for all the possibilities? I think we had to have for that one. Because we said there's no 6s in it anywhere. The problem exists here and there. Those are the ones that are too small. And why, Ronnie? You're seeing it. Why?
Because you can switch the place that the 6 occurs.
That's the problem. It goes back to yesterday, or I think it was yesterday, maybe the day before, when we had the 2 dice in our hands, and I said, make 3, and you went 1 and 2. And then I said, make 3 again. You're like, I can't. And I said, oh, you can. You got a yellow 1 and a red 2. Can't you have a yellow 2 and a red 1? That's where it becomes interesting, and that's where Cassidy's die simulator, where I'm able to project it, would be great. But you see, when I asked a bit of a loaded question. I said, Carly, where's the 6 going to be? And she said, in the first one. So if you imagine the dice is being colored red, white, blue, that forces the red die to be the 6. Does the 6 have to be on the red die? Couldn't it be on the white die? Or maybe even the blue one? Now let's go through this. Let's go through this and figure out. Now it's going to get kind of boring mathematically. If the 6 is going to be here, what would these numbers look like in this case? This would have to be a non-6. That would be
5.
This would be
1.
and this would be. Yes, very nice.
Do you just multiply those distributions by 3?
Hold that thought. Give me 30 seconds on that question, Carl. It's a fantastic question. This 6 has to be over here, right? 5, 5, 1. Now, the reason I'm pushing your question back 15 seconds or so, Carly, is what do we? This is 25, yes? And this is 25, and this is 25. What do we do with those 3 25s?
Add them up.
Why do we add them?
Because if you multiply them, it'd be over 216.
Oh, well, that's a good answer, Alan. That's a good mathematical answer. If you multiply them, you'd be over 216. Good. But in general, why would we add them?
Because you have 30 different probabilities.
Can I use a different word than different? Disjoint probabilities. This is your first project now. Get a dash, I'm pulling 2 projects right here. Say it with me. If you want to get 1 6 and your dice are red, white, and blue, the 6 will either be on the red die.
White die.
What was the word? I'm sorry.
The white die.
Before the word the, it's either going to be on the red die or the white die or remember the word or? Always needs to add. You're listing, as Monica said, statistically disjoint possibilities. There is no disjoint possibility for no 6s. You just don't get any 6s. There's no either or. You just didn't get 6s. As soon as you start mixing and matching the individual die and you have them be different inside, then you have to start keeping track of those disjoint possibilities, 6s versus non-6s. So what Carly just said is correct. You can just simply multiply the one we had over there by 3. But the reason is because you're adding it 3 times. That's why I wanted to make sure it wasn't just skipped right to multiplication. Because sometimes students forget the difference between exponentiation cubed and multiplication times 3. And this makes sure we understand why we are sometimes multiplying and sometimes adding. And do you see why we were multiplying in here? If you want the 6 to be on the red die, that means you have to have a 6 here and a non-6 here and a non-6 here. That's an and that's a multiplication. But then you have to add up all the disjoints with ors. So you got some ands and ors going on. Totally freaking rad. Carly, what's on your mind? Oh, nothing. I'm sorry. I thought you were going. So everybody see, this should be now. This should be 75. Yes, 3 times as big as it is. Yay! That means we're winning money a little bit more. Yes, that's good. Well, actually, it's just correct. I shouldn't say it's good. It's just getting correct now. Good. Good. We were wrong here. And where else, Carly? Aren't we? Do we have to also be wrong here? We have to be wrong here as well for the same reasoning, don't we? Because we forced, and Carly, thank you for doing this. You forced the 6s to be here. Where else could they be? The last 2, and Alan?
First and last.
The first and last. There's 3 different possibilities for those 6s too, aren't they? This gets more interesting when you have more dice. If we play Yahtzee, for example, this gets super interesting. No, just follow. You have to list out all the possibilities. You guys actually got a precursor to this back at 105 with that third project with the tree diagrams.
Right,
This is a breakdown of the tree diagrams, essentially, is what this is. You're doing it all. You're doing out the tree, essentially. So this is the non-6. That has to be 5, yes. And these are forced to all be 1s. And then the one last possibility is you can get the red and blue dice to be 6s and the white one in the middle to mismatch. Kels, make it sense? Ask me that question if you have one. Are you good? Okay. Sometimes I read faces wrong. So we can have a 6 here. We can have a 6. Am I getting all the possibilities?
Yeah.
We can't put them anywhere else, right? It gets more fun with more dice. And when I say more dice, I mean chickens, because on Tuesday we'll analyze. Anybody buying chickens this weekend? The day olds come out this weekend. And when you go in there, that's like rolling a die. Because they tell you they're girls, they tell you they're chicks, they tell you they're pullets. But they're not 100% correct, correctly sexed. They're sexed almost 100% correctly. So you roll a die when you grab a baby chick. Might be a rooster. So essentially you have to think about this if you want to say, okay, I need at least 10 chickens. I need at least 10 laying females. You've got to kind of analyze it this way. And we'll learn how to do that on Tuesday, which is too late for this weekend, I apologize.
It's a lot of eggs for a single family.
Well, it depends on what you're doing with them. Some people sell them.
Yeah, that's true.
Yeah, so for a single family, yes. For many single families, not so much though, right? Cool? And you guys analyze egg production, you see what happens in the winter. It tapers off pretty much. So even with 10 chickens, you might only get 4 or 5 eggs a week in the depths of the winter. So anyway, what should this number now be?
15.
Yes, it should be 15, shouldn't it? Because it's 3 times too small. Does this now check?
Yes.
Carly, go! Thank you. Yes, it does. Go, Carly.
Oh, well, I was just jumping ahead to the next one, because
This one here.
since it's all 1 in like 3 spots, does it just stay as 1 over
Has to.
216?
This one is 100% correct. If you think, I wish I had 3 dice. Can you make that be 3 6s? You have to keep rolling until you get it, don't you? Okay, don't do that. It's going to take you 216 friggin' times. No, the idea is, think about my die analogy, Carly. So red, white, and blue dice. Red, white, and blue. 6, 6, and 6. If I ask you to move the dice around to make a different outcome, you can't. They're already on the 6s, and they can't be rotated and changed. The reason we have to do this is because you have to rotate the dice. If the 6 is on this first one, the red die here, you can rotate the red one so it doesn't have a 6 in this outcome. Does that make sense?
Yeah.
You can't rotate this one. This one's done. 1, 2, 16 because you can't rotate it all. This one is interesting because some of these are going to be triples. You might triple 5s, for example, would be up here, wouldn't it? Triple 3s, triple 4s, all the ones you would have made you wish you betted on something else besides 6s, right? Triple 1s, triple 2s, triple 3s, triple 4s, triple 5s. Basically, everything up here doesn't have 6 on it. So you can ask yourself the question, okay, if I only had 5-sided dice, how many ways can I roll 5-sided dice? Well, 125. But that's the number of ways to not get 6s. That's the number of ways with 6s. Is that fair?
Yeah.
Now, if I may go back to Kendra's awesome idea, you can also think of this as 5/6 cubed. If you think of your last project, the way Kendra first postulated this was 1/6 cubed. Because in order to get three 6s, you have to first roll 1 6, which only happens 1/6 at a time. Then you've got to roll 1/6 again, which only happens 1/6 at a time. And then you got to roll 1/6 again, which only happens 1/6 at a time. So it's 1/6 to the 3rd power. This is 5/6 to the 3rd power. You've got to roll a non-6, which happens 5/6 at a time. Then you've got to roll a non-6 again, which happens 5/6 at a time. And you got to roll a non-6 again, which happens 5/6 at a time. Carly, is that fair?
Yeah.
You buying that?
Yeah.
You sure?
Yes.
Not just
No,
telling me
I
right
get
here.
it.
Okay, awesome.
It's like-
That's good for you. Now these happen interestingly enough. These also involve the 1s and 1/6 and 5/6s, but I want to hold that discussion for next week. I do with the chickens, because the numbers the chickens use are actually much more pleasant to use than these. The 6s multiply to make weird things, and the coefficients that we're coming up with, these 3s, are also very interesting. Go ahead, Linda.
So they all add up to 216.
Which is what they want to do.
That's what I was asking.
That's what we want. That was what Kelsey noticed right away, was we had a problem here. It didn't add up to 216 out of 216. Now it does. Which means now we have accounted for every single possibility. And I'm really hoping the network's back up, because I want to run the simulation now to see how close it comes to these.
It's not.
It's not back up. Shit. Okay, well that's okay. Take 5. Maybe we'll get a stay of execution in 5 minutes so we can fire it back up again. Cool? Let's kill the camera. If you guys have point questions, let's come deal with them.